OBJ is a geometry definition file format first developed by Wavefront Technologies for its advanced visualizer animation package. The file format is open and has been adopted by other 3D graphics application vendors. For the most part, it is a universally accepted format. The OBJ file format is a simple data format that represents 3D geometry alone, namely, the position of each vertex, the UV position of each texture coordinate vertex, vertex normals, and the faces that make each polygon, defined as a list of vertices, and texture vertices. Vertices are stored in a counterclockwise order by default, making explicit declaration of face normals unnecessary. OBJ coordinates have no units, but OBJ files can contain scale information in a human-readable comment line. File format: lines beginning with a hash character are comments. This is a comment. An OBJ file contains several types of definitions. List of vertices, with coordinates, W is optional and defaults to 1.0. V 0.1230.234 0.3451.0, B. Texture coordinates: in coordinates, these will vary between 0 and 1, W is optional and defaults to 0. VT 0.5001, 0, VT. Normals in form. Normals might not be unit. VN 0.707, 0.0000, 0.707, VN. Parameter space vertices in form. Free-form geometry statement, VP 0.31000003.2100002.100000, VP. Face definitions, F123, F3/14/2 and 5/3, F613375, F. Vertex positions, define points in parameter space of curve or surface. U only is required for curve points, U, and V for surface points and control points of non-rational trimming curves, and U, V, and W for control points of rational trimming curves. Face definitions: faces are defined using lists of vertex, texture and normal indices. Polygons such as quadrilaterals can be defined by using more than 3 vertex normal indices. OBJ files also support free-form curved surface objects, such as NURBS surfaces. Vertex: a valid vertex index starts from 1 and matches the corresponding vertex elements of a previously defined vertex list. Each face can contain 3 or more vertices. FV1 V2 V3. Vertex texture coordinate: optionally, texture coordinate indices can be used to specify texture coordinates when defining a face. To add a texture coordinate index to a vertex index when defining a face, one must put a slash immediately after the vertex index and then put the texture coordinate index. No spaces are permitted before or after the slash. A valid texture coordinate index starts from 1 and matches the corresponding element in the previously defined list of texture coordinates. Each face can contain more than 3 elements. FV1/VT1 V2/VT2 V3/VT3. Vertex normal: optionally, normal indices can be used to specify normal vectors for vertices when defining a face. To add a normal index to a vertex index when defining a face, one must put a second slash after the texture coordinate index and then put the normal index. A valid normal index starts from 1 and matches the corresponding element in the previously defined list of normals. Each face can contain more than 3 elements. FV1 VN1 V2 VN2 V3 VN3. Vertex normal: as texture coordinates are optional, one can define geometry without them, but one must put 2 slashes after the vertex index before putting the normal index. FV1 VN1 V2 VN2 V3 VN3. Other geometry formats: OBJ files support higher-order surfaces using several different kinds of interpolation, such as Taylor and B-splines, although support for those features in third-party file readers is far from universal. OBJ files also do not support mesh hierarchies or any kind of animation or deformation, such as vertex skinning or mesh morphing. Referencing materials: Materials that describe the visual aspects of the polygons are stored in external MTL files. More than one external MTL material file may be referenced from within the OBJ file. The MTL file may contain one or more named material definitions. MTL-lib, external MTL file name. This tag specifies the material name for the element following it. The material name matches a named material definition in an external MTL file. USEMTL, material name. Named objects and polygon groups are specified via the following tags. O, object name. G, group name. Smooth shading across polygons is enabled by smoothing groups. S1. Smooth shading can be disabled as well. S-off. Relative and absolute indices, OBJ files, due to their list structure, are able to reference vertices, normals, etc. either by their absolute position, or by their relative position. However, not all software supports the latter approach, and conversely some software inherently writes only the latter form, leading to occasional incompatibilities. Material Template Library, Synopsis. In 3D computer graphics, one of the most common geometry interchange file formats is the OBJ. The MTL file format is a companion file format that describes surface shading properties of objects within one or more OBJ files. An OBJ file references one or more MTL files, and from there, references one or more material descriptions by name. Introduction. The Material Template Library format is a standard defined by Wavefront Technologies for ASCII files that define the light-reflecting properties of a surface for the purposes of computer rendering, and according to the Phong reflection model. The standard has widespread support among different computer software packages, making it a useful format for interchange of materials. MTL files are commonly accompanied by and referenced from OBJ files that define geometry upon which the materials of the MTL file are mapped. The MTL format, although still widely used, is outdated and does not fully support later technologies such as specular maps and parallax maps. However, due to the open and intuitive nature of the format, these can easily be added with a custom MTL file generator. The MTL format defines a number of formats. Basic materials. A single MTL file may define multiple materials. Materials are defined one after another in the file, each starting with the NEWMTL command. Define a material named colored, NEWMTL colored. The ambient color of the material is declared using CAR. Color definitions are in RGB where each channel's value is between 0 and 1. CAR 1.000 white. Similarly, the diffuse color is declared using KD. KD 1.000 white. The specular color is declared using KS, and weighted using the specular exponent NS. KS 0.0000.0000.000 black, NS 10.000 ranges between 0 and 1000. Materials can be transparent. This is referred to as being dissolved. Unlike real transparency, the result does not depend upon the thickness of the object. D0.9 Some implementations use D, TR 0.9 others use TR. Multiple illumination models are available, per material. These are enumerated as follows. 0. Color on and ambient off, 1. Color on and ambient on, 2. Highlight on, 3. Reflection on and ray trace on, 4. Transparency, glass on, reflection, ray trace on, 5. Reflection, Fresnel on and ray trace on, 6. Transparency, refraction on, reflection, Fresnel off and ray trace on, 7. Transparency, refraction on, reflection, Fresnel on and ray trace on, 8. Reflection on and ray trace off, 9. Transparency, glass on, reflection, ray trace off, 10. Casts shadows onto invisible surfaces. Ilm 2. Texture maps, Textured materials use the same properties as above, and additionally define texture maps. Below is an example of a common material file. See the full Wavefront file format reference for more details. NEWMTL textured, CAR 1.00001.00001.000, KD 1.00001.00001.000, KS 0.0000.00000.000, D 1.0, ILM2, map CAR Lena TGA the ambient texture map, map KD Lena TGA the diffuse texture map. Most of the time, it will be the same as the ambient texture map, map KS Lena TGA specular color texture map, map NS Lena spec TGA specular highlight component, map D. Lena alpha TGA the alpha texture map, map bump Lena bump TGA. Some implementations use map bump instead of bump below. Bump Lena bump TGA bump map, disp Lena disp TGA displacement map, decal Lena stencil TGA stencil decal texture. Texture map statements may also have option parameters. Map CAR 0111 ambient TGA texture origin, riffle type sphere clouds TGA spherical reflection map. Texture options. Blend on offset horizontal texture blending, BLENDV on offset vertical texture blending, boost float value boost mip map sharpness, and base value gain value modify texture map values, base value equals brightness, gain value equals contrast, OU, V, W origin offset, SU, V, W scale, TU, V, W turbulence, text resolution texture resolution to create, clamp on-off only render texels in the clamped 0 to 1 range. When unclamped, textures are repeated across a surface. When clamped, only texels which fall within the 0 to 1 range are rendered. BM mult value bump multiplier. IMFCAN GBMLZ specifies which channel of the file is used to create a scalar or bump texture. R, red, G, green, B, blue, M, matte, L, luminance, Z, Z depth. Bump IMFCAN a bump map TGA says to use the red channel of bump map TGA as the bump map. For reflection maps, type sphere specifies a sphere for a riffle reflection map, type cube top cube bottom. When using a cube map, the texture file for each cube front cube backside of the cube is specified separately, cube left cube right. Vendor-specific alterations, because of the ease in parsing the files, and the unofficial spreading of the file format, files may contain vendor-specific alterations. According to the spec, options are supposed to precede the texture file name. However, at least one vendor generates files with options at the end. Bump text bump TGA BM 0.2 bump multiplier of 0.2. See also, 3DMLW is a markup language that shows OBJ files through common web browsers. STL, PLY is an alternative file format offering more flexibility than most stereolithography applications. References. External links, OBJ specification, MTL specification, tools, libraries and example files.